Hi, welcome to iEducator. This is Teacher Jeff. I'm an educator and an engineer by profession. And today we will discuss Chapter 1. And Chapter 1 is all about the introduction to quality. Now, in this lesson, there are four key areas that I'm going to be covering today. First, the definitions of quality. Second, the Statistical Quality Control or SQC. Third, dimensions of quality. And lastly, the Total Quality Management or TQM. So what is meant then by quality? Remember that quality means different to different people, right? Now, in this case, there are 5 ways of looking at quality definition. First is customer base. Second is manufacturing base. Third is value base. Fourth is product base. And lastly, we have transcendent. Now, as a customer base definition, according to Edwards 1968, he defined quality as consists of the capacity to satisfy wants. Also, Gilmore 1974 defined quality as the degree to which a specific product satisfies the wants of a specific consumer. And in addition, Cohen and Day 1962 said that in the final analysis of the marketplace, the quality of a product depends on how well it fits patterns of the consumer preferences. Now, as you can notice, looking at this definition of quality, we can say that it's actually about satisfying customers' wants and needs. Now, the main reason businesses need to satisfy customers' wants and needs is because in the manufacturing aspect of the business, it is the easiest way to increase profits and sell more products and services. Now, that being said, it is imperative for businesses to find what the customers are longing for and needing, as it serves as a key point of differentiation that helps them to attract new customers in competitive business environment. In addition, Duran 1988 defined quality as fitness for use. Now, what do we mean by this? So what Duran meant about this is that this definition of quality really resonates with us. This further means that a high quality product does what its customers want in such a way that they actually use the product. And lastly, we have Oakland 1989, and he said the core of a total quality approach is to identify and meet the requirements of both internal and external customers. This means that not only should we meet the requirements of our external customers, but also with the internal customers or those employees working in the organization. Now, another way of looking at the quality definition is through manufacturing base. And as you can notice, according to Crosby 1979, quality means conformance to requirements. This means that every product or service has a requirement, which is a description of what the customer needs. And these requirements must be detailed in clearly stated terms that describe what is exactly being asked for in the end product or service. On the other hand, Price 1985, he defined quality as do it right the first time. Now, in this definition of Price, the right thing refers to the customer's requirements. Again, the right thing that Price is referring to This refers to the customer's requirements. The organizational performance standard for providing work is do the right thing. And doing the right thing means meeting the customer's requirements right the first time. And another way of looking at the quality definition is through value-based definition. And according to Braun 1982, quality is the degree of excellence at an acceptable price and the control of variability at an acceptable cost. In here, quality means best for certain customer conditions. And these conditions are first, the actual use, and second, the selling price of the product. On the other hand, according to Kanji 1990, quality is to satisfy customers' requirements. And TQM is to achieve quality at low cost by involving everyone's daily commitment. Okay? And another way of looking at a quality definition is that quality can also be defined based on product itself or product-based definition. And according to K.B. Leifler 1982, quality refers to the amount of the unpriced attributes contained in each unit of the price attribute. And lastly, another way of looking at a quality definition is through transcendent. And according to R.M. Persig, quality is neither mind nor matter, but a third entity independent of the two. Even though quality cannot be defined, you know what it is. Now, this means that quality is not clear what it is, but it is something good. Now, the expression quality has to be understood clearly from the customer point of view for the success of TQM program. And one usually thinks about quality in terms of an excellent product or service that fulfills or exceeds the expectation. These expectations are based on the intended use and the selling price. Now, if a product or service surpasses the expectations, one related with the quality, and therefore, it is more or less an intangible thing based on perception. And the quality can be quantified as Q equals P over E, where Q refers to quality, P refers to performance, and E refers to expectation. Now remember, if Q or your quality is greater than 1, then the customer has a good feeling about the product or service. It should be noted as well that based on perception is determined by the organization. And it should also be noted that expectation is determined by customers. And as per ISO 9000 series of 2000, quality is defined as the degree to which a set of inherent characteristics fulfills requirements. If we say degree, it means that quality can be used with adjectives such as poor, good, and excellent. And if we say inherent, it means existing in something, especially as a permanent characteristics. And if we say characteristics, it can either be quantitative or qualitative characteristics. And if we say requirement, it is a need or expectation that is actually stated and generally implied by the organization, its customers, and other interested parties. Now, in our statistics subject, we learned that statistics is the study of the collection, analysis, interpretation, presentation, and organization of data. And when we say statistical tools, these are the applications of statistics for the purpose of visualizing, identifying, and predicting results based on the data collected. And therefore, statistical quality control is the collection, analysis, and interpretation of data for use in quality control activities. And there are three basic measurement concepts of SQC, or statistical quality control. The first basic measurement concept is descriptive statistics. Second, we have statistical process control. And lastly, we have acceptance sampling. And acceptance sampling is composed of lot-by-lot sampling, continuous production, and acceptance sampling for variables. Therefore, when we say statistical quality control, it is the collection, analysis, and interpretation of data for use in quality control activities. It is typically the measuring and recording of data against specific requirements for a product, ensuring they meet the necessary requirements such as size, weight, color, etc. And it is composed of three basic measurement concepts. We have descriptive statistics. Second, we have statistical process control, or SPC. And lastly, we have acceptance sampling. And acceptance sampling is composed of lot-by-lot sampling, continuous production, and acceptance sampling for variables. Now, let us discuss first descriptive statistics. When we say descriptive statistics, it is used to describe quality characteristics and relationship, meaning it is applied to a population of data and are used to describe the data in that population. Examples of descriptive statistical tools that we will be using will be measures of central tendency or location. We also have measures of dispersion or the spread. We also have measures of skewness and kurtosis or shape. And we also have histogram. The second basic measurement concept of statistical quality control, that would be statistical process control, or SPC. If we say SPC, this involves inspecting a random sample of the output from a process and deciding whether the characteristics of the products in the sample fall within a predetermined range. One example of statistical process control, that would be variations. And variations is divided into two types. First, we have common cause, and second, we have special cause. Now, we know for a fact that in manufacturing setting, quality is defined as conformance to specifications. However, no two products or characteristics are ever exactly the same because any process contains many sources of variability. As manufacturing, traditionally, the quality of a finished article is ensured by post-manufacturing inspection of the product. And each article or a sample of articles from a production lot may be accepted or rejected according to how it meets its design specifications. In contrast, SPC, or statistical process control, uses statistical tools to observe the performance of the production process in order to detect significant variations before they result in production of a substandard article. Any source of variation at any point of time any process will fall into one of the two classes. First, we have common causes, and second, we have special causes. Now, if we say common causes, these are sometimes referred to as non-assignable or normal sources of variations. It refers to any source of variation that consistently acts on process of which there are typically many. And these types of causes collectively produce a statistically stable and repeatable distribution over time. It is also predictable, and because it's predictable, we can control it. On the other hand, if we say special causes, these are sometimes referred to as assignable sources of variation. It referred to any factors causing variation that affects only some of the process output. And these types of causes are often intermittent and unpredictable. And because it's unpredictable, therefore, these are the ones that can cause harm on our process. Now, to make it simpler and more understandable, common causes can be likened to a normal modern traffic we experience on our daily commute, while special causes can be likened to when there is an accident plus a heavy traffic comes to complete standstill. Okay? Aside from variations, another example under SPC or Statistical Process Control, that would be control charts. Popular SPC tool originally developed by Walter Shewhart in the early 1920s. Of the control chart tools that we're gonna be employing, that would be the average and range. We also have individual and moving range. We have P chart, C chart, and short run as well. Now, this is an example of a control chart. Now, as you can see on the graphical presentation, the best method that is employed in studying causes of variation is the control chart method. This means that a control chart could help us understand if the process is in state of control or not. As you can see, data are plotted in time order, correct? Our horizontal line, or our x-axis, serves as our time. It doesn't say though if it is in terms of minutes or hours, but let's just assume the unit of measure is in minutes. And aside from time, a control chart always has a central line for the average. We call it process average. And aside from that, the broken lines in red represent our control limits. So in this case, we have UCL, or upper control limit, and LCL, we have lower control limit. Now, these lines are determined from historical data. And by comparing current data to these lines, we can actually draw conclusions about whether the process variation is consistent or in control, or unpredictable or out of control, affected by special causes of variation. And as you can see on the graphical presentation, our common causes are located inside our control zone or inside our control limits, which means that the processes are in control. On the other hand, special causes of variation are located outside our control zone, which means they are out of control. And because they are out of control, then these can harm our processes. So what do we do then if we have special causes of variations like this? Well, if our processes are out of control, we need to conduct an Ishikawa study, or also known as fishbone or cause and effect study, in order to analyze the process, take corrective actions, eliminate the root cause of the problem, and make sure we are able to bring that process back to our control zone. And so, as a summary, when do we use a control chart then? Now, we can use control chart first when controlling ongoing processes by finding and correcting problems as they occur. And second, we can use control chart when predicting the expected range of outcomes from a process. Third, we can use control chart when determining the stability of our process. Fourth, we can use control chart when analyzing patterns of process variation from special causes or common causes. And lastly, we can use control chart when determining whether your quality improvement project should aim to prevent specific problems or to make fundamental changes to the process. Okay, so, and the last basic measuring concept of SQC is called acceptance sampling. And if we say acceptance sampling, this involves random inspection of a sample of goods, and based on the results of the sample, a decision is made as to whether a batch of goods should either be accepted or rejected. So the sample tools that we're gonna be employing if we conduct acceptance sampling, that would be risks, OC curves, AOQ, AOQL, ASN, ATI, and ANSI standard. Okay, now moving on to our next key area. So the next key area that we're gonna be discussing today would be the dimensions of quality. Now, we need to understand that product quality is one of the leading positioning tools used by marketers for the promotion of their product. Now, constantly improving the quality of our products and services is very essential to remain competitive in the marketplace. Now, with the advent of the increased level of competition, companies nowadays have renewed their focus on quality to maintain the demand for their products and services. In fact, Japanese companies, for instance, have been practicing TQM, or Total Quality Management, for a long time. And it is an important factor that turned Japan into an economic powerhouse. However, we need to understand as well that managing quality is not simply, and that it requires dedication and continued focus on quality improvement. And that brings us to dimensions of quality. So what are the 9 dimensions of quality? The 9 dimensions of quality, we have performance, features, reliability, conformance, durability, serviceability, aesthetics, response, and reputation. Now, let us discuss first performance. What do we mean by performance dimension of quality? If we say performance, it refers to a product's primary operating characteristics. This dimension of quality involves measurable attributes. Let's say brands can usually be ranked objectively on individual aspects of performance. Later on, we will have a clear example about each of these dimensions of quality. Now, another dimension of quality, we have features. Features are additional characteristics that enhance the appeal of the product or service to the user. And when we say reliability, it is the likelihood that a product will not fail within a specific time period. This is a key element for users who need the product to work without fail. And if we say conformance, it is the precision with which the product or service meets the specified standards. And if we say durability, durability measures the length of a product's life. When the product can be repaired, estimating durability is more complicated. Now, the item will be used until it is no longer economical to operate it. And this happens when the repair rate and the associated costs increase significantly. On the other hand, serviceability is the speed with which the product can be put into service when it breaks down, as well as the competence and the behavior of the service person. And if we say aesthetics, it is the subjective dimension indicating the kind of response a user has to a certain product. It actually represents the individual's personal preference. And when we say response, it refers to human interface. So an interface between a customer and a dealer. And lastly, we have reputation. And if we say reputation, this refers to past performance of the company's product. And primarily, it is based on the perceived quality of the product or brand. Now, in order for us to better understand these 9 dimensions of quality, then let us have a specific example. Now, our example, this is courtesy by Canopus Business Management Group. And in this particular example, this is an example of a car, okay? So let's have performance dimension of quality first. Now, in a car, let's say a Safari car. Now, in performance, Safari should increase speed from 0 to 100 kilometers per hour in 15 seconds. And the mileage, that's 13.2 kmpl. Okay, that's an example of performance. What about features? If we say features, in a car or in a Safari car, it should be convenient for the drivers. Power steering, rear AC ventilations, adjustable seats, central locking, airbags are just some of the many examples that will provide convenience to the drivers of the car. And if we say conformance, car matches manufacturer's specifications. They should pass all conformance tests, meaning to say the manufacturer of the car is able to meet the customer's requirements or specifications. That is why there is conformance to standards. Next, we have reliability. Under reliability, there should be no need for repairs, okay? So meaning to say, your car, your Safari car should be reliable. It should not break down right away. Next, we have durability. When we say durability, this is resistant to water and rust, meaning long life, okay? If we say service, there should be proper after-sale service, meaning to say, in event you have a broken car, then there is what we call warranty, okay? You can take advantage of a warranty. So that's what we call after-sales service. And if we say experience, this is also known as the reputation or the perceived quality. If we say experience, it should be a top-rated car. So you are a reputable company or a reputable manufacturer. And if we say aesthetics, these refer to exterior and interior design, and it should be better than industry standard. All right, so these are examples of each of our dimension of quality. And the next key area that we will be covering in this lesson would be TQM, or Total Quality Management. So what is meant then by TQM? If we say TQM, this is defined as both a philosophy and a set of guiding principles which represent the foundation of a continuously improving organization. It is defined as both a philosophy and a set of guiding principles because the core definition of TQM describes a management approach to long-term success through customer satisfaction. And because we want to meet or exceed customer specifications in order to satisfy them, therefore, in a TQM effort, all members of an organization should participate in the continuous improvement of the processes, products, services, and the culture in which they work. Second, when we say total quality management, it is an enhancement of the traditional way of doing business. If we say total, it means made up of a whole. If we say quality, it means degree of excellence a product or service provides. And if we say management, it is an act, art, or manner of handling, controlling, or directing. And so for that matter, etymologically speaking, TQM is the art of managing the whole to achieve excellence. Okay? Now at this point, we're gonna be diving in deeper about the antecedents of modern quality management as to how quality or quality management really started. Now specifically, we're gonna be exploring what really happened during the guilds of medieval Europe, the Industrial Revolution, the World War II, and the post-World War era. Now, so this is how your antecedents of modern quality management look like. To start with, the quality movement can trace its roots back to medieval Europe, where craftsmen began organizing into unions called guilds in the late 13th century. Craftsmen themselves often placed a second mark on the goods they produced. At first, this mark was used to track the origin of faulty items, but over time, the mark came to represent a craftsman's good reputation. Inspection marks and master craftsmen marks served as proof of quality for customers throughout medieval Europe. And this approach to manufacturing quality was dominant until the Industrial Revolution in the early 19th century. Until the early 19th century, manufacturing in the industrialized world tended to follow this craftsmanship model. Now, the factory system, with its emphasis on product inspection, started in Great Britain in the mid-1750s and grew into the Industrial Revolution in the early 1800s. American quality practices evolved in the 1800s as they were shaped by changes in predominant production methods. And in the early 19th century, manufacturing in the United States tended to follow the craftsmanship model used in European countries. Since most craftsmen sold their goods locally, each had a tremendous personal stake in meeting customers' needs for quality. Now, if quality needs were not met, the craftsman ran the risk of losing customers not easily replaced. And so for this matter, masters maintained a form of quality control by inspecting goods first before sale. And the factory system, a product of industrial revolution, began to divide the craftsman's trades into specialized tasks. This forced craftsmen to become factory workers and forced shop owners to become production supervisors, and marked an initial decline in employees' sense of empowerment and autonomy in the workplace. Quality in the factory system was ensured through the skill of laborers, supplemented by audits and or inspections. Defective products were either reworked or scrapped. Now, late in the 19th century, the United States broke further from European traditions and adopted a new management approach developed by Frederick W. Taylor, whose goal was to increase productivity without increasing the number of skilled craftsmen. He achieved this by assigning factory planning to specialized engineers and by using craftsmen and supervisors as inspectors and managers who executed the engineers' plans. Now, Taylor's approach led to remarkable rises in productivity, but the new emphasis on productivity had a negative effect on quality. To remedy the quality decline, and in order to remedy the quality decline, factory managers created inspection departments to keep defective products from reaching customers. And after entering World War II, the United States enacted legislation to help gear the civilian economy to military production. During this period, quality became a critical component of war effort and an important safety issue. Unsafe military equipment was clearly unacceptable, and the US Armed Forces inspected virtually every unit produced to ensure that it was safe for operation. This practice required huge inspection forces and caused problems in recruiting and retraining competent inspection personnel. And in order to ease the problem without compromising product safety, the armed forces began to use sampling inspection to replace unit by unit inspection. With the aid of industry consultants, particularly from Bell Laboratories, they adopted sampling tables and published them in a military standard known as MIL/STD 105. MIL stands for military and STD stands for standard. So the military standard was known as MIL STD 105. And these tables were incorporated into the military contracts, so suppliers clearly understood what they were expected to produce. And the armed forces who helped suppliers improve quality by sponsoring training courses in Walter Schuhart's SQC techniques. Now, the quality in the early 20th century, at the beginning of the 20th century, marked the inclusion of processes in quality practices. A process is defined as a group of activities that takes an input, adds value to it, and provides an output. Walter Schuhart began to focus on controlling processes in the mid-1920s, making quality relevant not only for the finished product, but for the processes that created it. And aside from that, Schuhart recognized that industrial processes yield data. Schuhart determined that this data could be analyzed using statistical techniques to see whether a process is stable and in control, or if it is being affected by special causes that should be fixed. And in doing so, Schuhart laid the foundation of control charts, which is a modern day quality tool because up until today, we are still using it. On the other hand, William Edwards Deming, a statistician with the U.S. Department of Agriculture and Census Bureau, became a proponent of Schuhart's SQC methods and later became a leader of the quality movement in both Japan and the US. And the history of total quality in America, the birth of total quality in the US was in direct response to a quality revolution in Japan following World War II, as major Japanese manufacturers converted from producing military goods for internal use to produce civilian goods for trade. Now, at first, Japan had a widely held reputation for shoddy exports, and their goods were shunned by international markets. This led Japanese organizations to explore new ways of thinking about quality. Now, the Japanese welcomed input from foreign companies and lecturers, including two American quality experts. First, we have William Edwards Deming, and second, we have Joseph M. Juran. William Edwards Deming, who had become frustrated with American managers when most programs for SQC were terminated once the war and government contracts came to an end. On the other hand, Joseph M. Juran, who predicted the quality of Japanese goods would overtake the quality of goods produced in the US by the mid-1970s because of Japan's revolutionary rate of quality improvement. So how did Americans respond to TQM practices of Japan? Now, at first, US manufacturers held onto to their assumption that Japanese success was price related and therefore responded to Japanese competition with strategies aimed at reducing domestic production costs and restricting imports. This, of course, did nothing to improve American competitiveness in terms of quality. So as years passed, price competition declined while quality competition continued to increase. Now, the chief executive officers of major US corporations stepped forward to provide personal leadership in the quality movement. And the US response, emphasizing not only statistics, but approaches that embrace the entire organization. And it became known as TQM, or Total Quality Management. So several other quality initiatives followed. First, we have ISO 9000 series of quality management standards. Second, quality initiative followed. We have the Baldrige National Quality Program. And we also have third, Malcolm Baldrige National Quality Award. Okay. And finally, as the 21st century begins, the quality movement has matured. New quality systems have evolved beyond the foundations laid by Deming, Juran, and the early Japanese practitioners of quality. Some examples of this maturation in quality management include, first, most recently in 2015, the ISO 9001 standard was revised to increase emphasis on risk management. Second, in 2000, the ISO 9000 series of quality management standards was revised to increase emphasis on customer satisfaction. Third, beginning in 1995, the Malcolm Baldrige National Quality Award added a business result criterion to its measures of applicant success. Next, we have Six Sigma, which is a methodology developed by Motorola to improve its business by minimizing defects, evolved into an organizational approach that achieved breakthroughs and significant bottom line results. And lastly, Quality Function Deployment, or QFD, which was developed by Dr. Yoji Akao as a process for focusing on customer wants or needs in the design or redesign of a product or service. All right, so this ends our discussion for the antecedents of the modern quality management. And lastly, we have the scope of total quality management activity. So the total quality management is divided into two scopes. First, we have the principles and practices, and second, we have tools and techniques. In the first scope, which is the principles and practices, this involves leadership, customer satisfaction, employee improvement, supplier partnership, and finally, we have performance measure. And on the second scope of TQM, which is the tools and techniques, this is divided into two parts. First, we have the quantitative tools and techniques. And second, we have non-quantitative tools and techniques. Under quantitative tools and techniques, it involves SPC, or Statistical Process Control. We also have acceptance sampling, reliability, experimental design, Taguchi's quality engineering, FMEA, or failure modes and effects analysis, and we also have QFD, or quality function deployment. On the other hand, for non-quantitative tools and techniques, it involves ISO 9000, ISO 1400, benchmarking, we have TPM, management tools, and product liability. All right, so that ends our discussion for chapter 1, which is the introduction of qualities. So if you have questions, please let me know in the comment section. All right, so if you like this video, please don't forget to subscribe and hit the bell button for the latest updates. Thank you.